Okay, welcome back. In this fourth video on hypothesis testing, we're going to look at some common errors and pitfalls that people make when they perform hypothesis tests. But before we do that, I want to go through and do a brief review. The last three videos we've covered a lot, and I'd like to go through and kind of make sense and synthesize everything that we've done so far. So we'll call this review, and hopefully this will help you put everything together. So in part one, the key take-home message there was that a hypothesis test is really a test of a parameter's value. So a hypothesis test is where we're testing a parameter's value. Now, we mentioned before in chapter 2 that a statistical question is always a question about the value of a parameter. And so one question we can have is we can say, does our parameter have a specific value? And that's what a hypothesis test does. It answers this question. Now, where does that specific value that we're referring to come from? Well, this was really the topic that we covered in part 2. So part 2 talked about how we formulate this question in a statistical manner, but also the sort of applications in which these sorts of questions arise. So how do we get hypothesis tests? So how do we get our hypotheses, and where do hypothesis tests arise? And these two things are actually related. Don't want to put my eyes in there. I don't know why it's doing that. Okay. So this was the import of part 2. And what we saw is that there were 3 different common situations where we had hypothesis tests, and the same sort of logic or thinking was really going on each of them, okay? So first we had a manufacturer's claim. That was one. Application. We might want to test a manufacturer's claim. Another is that we have a change that occurs that we think affects our population. And the third is that our population may have some sort of property, and we want to test to see if it has that. And so we could give kind of basic sort of problems to flesh out these these general cases, okay, so that's a little more specific. So for example, Raisin Bran may claim that the average amount of cereal in their boxes is 16 ounces. Okay. We may have a situation when we're thinking about a scenario where a change occurs, we may have a situation where a law is enacted. So for example, we may know that before a mandatory helmet law is enacted, the fatality rate in motorcycle accidents, so we might say that the percentage of motorcycle accidents that ended in fatalities before a mandatory helmet law was enacted was, and I'll just make up a number, say the percentage of those accidents that were fatal were 11%. And finally, the last thing is we might be looking to see if a population has some property. So there might be some characteristic of a property that we can quantify, and we want to see if it has that property. And so, for example, the male rat empathy experiment was a good example, right? We were testing to see are they empathetic? And we found a way to quantitate empathy as the percentage of times the populations in that the rats in that population would open a door to help another rat. Okay. And of course, if they didn't have empathy, right, the percentage of rats that would open the door would be 50% or less. They'd be indifferent or they'd be anti-empathetic. Okay. And so kind of the thing to take home from here is that if we go back to this general setting of hypotheses, we have two hypotheses, right? So the first hypothesis is called the null hypothesis. And these hypotheses here would be the null hypothesis in each case. In other words, this is the hypothesis we would believe if we had no evidence or no data. Okay, so this is the hypothesis that we believe either due to prior information, past history, or maybe in the absence of any data. So for example, with a manufacturer's claim, Raisin Bran claims they have an average of 16 ounces in their box. If we didn't have any evidence to the contrary, we would believe that. Nobody goes home and weighs their boxes of cereal, right? Okay, so this is kind of the default belief. If you didn't produce evidence to show that Raisin Bran didn't meet this claim, I would assume they did, and we do every day. The same sort of thing here, right? If we didn't have any evidence to show that the law actually reduced the fatalities, we would assume that the parameter still has the same value as before. And we call this value, we give a special notation. This value that we believe under the null hypothesis is represented by the parameter symbol, mu naught is equal to 16. This is saying this is the parameter value under the null hypothesis. Null means nothing. Nothing happened, right? In other words, the manufacturer, they met their claim. Nothing happened, okay? So think of 0 as being null. Here we would write this as pi sub 0 is equal to 11%. The population percentage we would believe under the null, that is that the population didn't change after this particular change occurred, is 11%. And the same thing with the male rat empathy test, right? If we had no evidence they were empathetic, what would we assume? We would assume that they aren't. So we would assume that pi is equal to 50%. So this is the value that we believe the parameter has in the absence of any evidence. Now, the alternative is what you're trying to prove. So the alternative hypothesis this is what we're trying to prove. So if we go through each of these examples, right, if you think about a class action lawsuit, what are you generally trying to prove? You're generally trying to prove that the population average weight is less than the manufacturer's claim, right? So the alternative hypothesis here would be what we're trying to prove is that mu is less than 16. Most likely in the situation where a change occurs, especially in this particular scenario with the motorcycle helmet, what would we expect to happen, right? What would we try to prove? Well, what is the purpose of the law? It's to reduce fatalities and the severity of accidents, right? And so what we would be trying to prove is we'd be trying to prove that now the population proportion is less than 11%. So this is what we'd be trying to prove in each of these cases, right? In the case of the male rat empathy experiment, what were we trying to prove? Well, we were trying to prove that rats were empathetic, and we said that we would say rats were empathetic when more than 50% of the population would help a caged rat, a trapped rat. So these are the alternative hypotheses, okay? And so this kind of helps us learn how to set up things. Notice that you have to read the problem carefully. The alternative is what you're trying to prove. Sometimes it's kind of implied, right? Like with a manufacturer's claim, what are you trying to prove? You're always trying to prove against the manufacturer's claim. But it's going to be not in their favor, right? For example, you could test to see if the average was greater than 16 ounces. Would anyone care? No. I mean, maybe Raisin Bran might care, right? But if we're talking about a class action lawsuit, it's obvious that we're testing to see if they're getting less than what the manufacturer advertised, okay? And so finally, in part 3, we talked about, well, what is the logic behind how this happens? And so we introduced this analogy with a court trial. So here we talked about the logic of how a hypothesis test worked. And we said, okay, just like in a court trial, we have two hypotheses, okay? So this is court, and this is a statistical hypothesis test. People abbreviate hypothesis test HT, okay? So in a court of law, you have two hypotheses, right? The null, what we believe about the person, if there was no evidence to the contrary, right, would be that they're not guilty. This is what's presumed to be true in the absence of any evidence about that person. The alternative, which is what the prosecutor is trying to prove, is that you're guilty. And to kind of flesh this out and put this in the context of a statistical hypothesis test, I'm going to use the male rat empathy experiment, okay? So the null here, we said it was that they're not empathetic. Sometimes people call the null hypothesis the no news hypothesis. Okay, so there's a couple of different ways of looking at the null hypothesis. That is to say, it's a thing that if it occurred, you wouldn't write a story about it. If people found out, for example, that male rats were not empathetic, probably nobody would write a story about that, right? It's the empathetic male rats that make it interesting. So if they were not empathetic, they'd be indifferent or worse. And all I have to prove is indifferent, right? If I can prove indifferent, I've proven that it's less than or equal to 50%. And the alternative, which is what the researchers are trying to prove, is that it's greater than 50%. The alternative hypothesis, when I was a student, when I went back and I read the really old papers, they actually had a slightly different name for the alternative, and I like it better. Sometimes people call the alternative hypothesis the research hypothesis. In other words, it's the thing that you're trying to research, that your study is trying to show. And so we set up our hypotheses. One thing to kind of notice that you're going to have to read the problem carefully to figure out, first of all, what is the parameter value? And secondly, what is the alternative? In other words, what it is that we're trying to prove. And this again is where we're going to go back and use the skills that we learned way back in chapter 2 of how to take apart a problem, right? So here, what am I going to have to identify? I'm going to have to identify my parameter, right? My variable and my population. And these are all things that will help you with this first step. Okay, then what happens? Well, then evidence is presented, right? So then the prosecutor goes ahead and presents his evidence. And so if we think about this in the context of a hypothesis test, what would be the evidence that the population percentage is greater than 50%? Well, it would be the sample percentage, right? And we found out in the male rat empathy experiment it was roughly 70.8%. Now, one thing to notice is that the sample estimate always has to be in favor of the alternative when we run a hypothesis test. So this is kind of important, okay? So the estimate, in other words, the evidence, these two things are really equivalent in this sense. The estimate always has to be in favor of the alternative. And this example is not the best example to illustrate this point. So let me go back up to this example with the Raisin Bran, okay? If you were to try to make a class action lawsuit against Raisin Bran, and you went out and got evidence, right? What would your evidence have to be? If you found, for example, that the sample average was greater than 16, could you use that as evidence that the population mean is less than 16? Well, think about it for a minute. You go into a court of law, the judge says, okay, what are you trying to show? And you say, well, here, Your Honor, I'm here to show that Raisin Bran's ripping off their customers and the average weight in their boxes is actually less than the advertised amount of 16 ounces. And the judge says, okay, what is your evidence? You say, well, we took 100 boxes, we weighed them, and the sample mean of those 100 boxes was 16.5 ounces. The judge is going to look at you like, what are you doing here, right? You know, you're trying to prove it's less than 16 ounces and your evidence shows the opposite. So it's important to understand that, okay? The evidence always has, there's some evidence in favor of the alternative, just like there's some evidence in favor of a person being guilty. You can't just drag a person into court for no reason. The question is there enough? Okay? Now, this is where we introduce the central limit theorem. So now what we want to do is we want to weigh the evidence. Okay? And in a jury, what they're doing is they're looking at all of the evidence against that person, and they're asking if the person is innocent. Well, I should say not guilty. There is a difference in this context. So if the person is not guilty, then how likely is it I could get all this evidence against them? In other words, is it likely that a person that's not guilty could have all this evidence against them? This is kind of the mental calculus that the jury is going through. And so if you think about, say, a capital murder trial, right? And, I am accusing someone of, killing an individual. There has to be some evidence, right? So first, you hear the defendant arguing with the deceased, right? Okay, that's some evidence, right? Then they threaten to kill them. Well, that's a little more evidence. But it's still possible that the person could not be guilty given this evidence. Okay, it isn't that unusual for people to say, I hate you, I'm going to kill you. It happens. Okay? And then there's more evidence, right? So they were seen leaving the scene of the crime. Now it becomes less likely that they're not guilty, right? And then you find the murder weapon at their house and a motive. And eventually it gets to the point where there's so much evidence, this probability becomes so low they switch sides. Okay, let's put this in the context of a hypothesis test. So what's going on is, if the person's not guilty translates to if the null hypothesis is true. In other words, in this situation, pi is really equal to 50%. And it's important to understand this is not just a statement about the parameter's value. It actually dictates what estimators have to look like. In other words, this hypothesis dictates what these guys have to look like. Because as a consequence, the central limit theorem tells us then that sample estimates under the null hypothesis, okay, these are sample percentages that were drawn from a population where pi naught's equal to 50%. Okay, these are sample percentages from this population. They have to look like this. So if the null hypothesis is true, if the person's not guilty, this is what an estimator should look like. And so what we did in our male rat empathy experiment was we looked at our evidence. Our evidence here is 70.8%. And we asked, if the null hypothesis is true, then how likely is it that we could get this evidence, this sample estimate? And we know that how likely is code word for percentile. And so we were able to use a normal distribution and the central limit theorem to figure out how likely it is that we could get our observed sample percentage if it came from a population of indifferent rats. And what we found was this percentile was less than 2%. And we said this percentile we call a p-value. So the p-value is how likely we are to get an estimator as extreme or more extreme than what we observed if the null hypothesis was true. Okay? So what we do is we look at the alternative here, okay? And we say how likely is it that we get an estimator 70.8% or larger if the null hypothesis is true. Okay? And we found out in this case the p-value was, in our particular case, was actually less than 2.5%. And the way we make this determination, just like the jury, at some point they have to draw a line in the sand, and they have to say there's too much evidence to hold on to our old belief that they're not guilty. We're going to switch beliefs and say that they're guilty. By the same token, there has to be a line in the sand for when this is too unlikely to occur. Okay? In other words, we're going to switch from this belief to this belief because with the evidence we have, it's too unlikely that this could be true. This line in the sand is called the level of significance. Okay? So alpha, which stands for the level of significance, is the smallest p-value for which we can still believe the null. So in other words, when the p-value is less than alpha, we're going to reject the null. In the same way that when the likelihood the person can be innocent, given all the evidence, is less than some threshold, the jury flips. They say, we don't believe the null anymore. We don't believe they're not guilty. We believe they're guilty. And if the p-value is greater than alpha, we fail to reject the null. In other words, we're not saying that the null hypothesis is true. We're saying there's some evidence to reject it, but not enough. In the same way that a jury, when they come back, they never say a person's innocent. They say there's insufficient evidence to prove guilt. I mean, you may be looking at someone, you may know they're guilty of sin, but if you can't present the evidence, that there's not enough evidence, the jury has to fail to reject the null. They have to fail to jump to the other side. Okay, I thought this was kind of a good thing to put together just to review where we're going. And in the next video, actually, I'm going to start part 4. So you could think of this as part 3.5, just to kind of synthesize and bring together everything that we've learned so far.